you guys will be able to apply properties of systems of real-world scenarios. We're going to finish up section 5.4, okay? So we have a little bit more to do in section 5.4.
Today's Wednesday? Oh my god.
Today is Tuesday. Hence why I'm wearing a trooper tie and not pink. Alrighty. So, voice off, guys. We're going to go back to example 1, 2, and 3 and look up how we set these up to give us some help in how to set up number 4. So number 1, we said the important information was the fact that there was a $50 sign-up fee. It cost $75 per month. $30 sign-up fee, $80 per month. And we want to know after how many months will the cost be the same? And we want to know what the cost will be. Now, it also might be good to know that we had a first plan and we had a second plan. So what we did was we said the $50 sign-up fee plus $75 per month, X or M, I think we called it M, was equal to Y, our costs. And we can call the variables anything. We just called it M for months. Yep. The second plan was a $30 sign-up fee plus $80 per month. And we wanted the cost to be the same, so we also called it Y. And then we solved these, okay? So this was first plan, second plan. Now notice, the first plan is the first equation. The second plan is the second equation. So the first plan ended up being the first equation. The second plan ended up being the second equation. On number 2, one cable provider had a $60 setup fee, cost $80 per month. The second has a $160 equipment fee and costs $70 per month. And we want to know how many months will the cost be the same, and what will that cost be? So our equations was a $60 setup fee plus $80 per month, which we also called M, equals the cost Y. $160 equipment fee plus $70 per month is equal to the same Y. Notice again, first plan, first cable company is the first equation. Second cable company, second equation. We noticing kind of a theme there?
Yeah.
Okay, when we heard there was one plan, a second plan, or one company, another company. Aiden, put it away. Okay? Now, number 3 was a bit different. Number 3, were there 2 different companies? No. We had Sam spent a total amount to buy a total number of flowers. We were given 2 different total numbers. We were told he spent this much total, and he bought this many flowers total. We were given 2 total amounts. And we were told it contained roses and daisies, and that roses are $2.50 each, daisies are $1.75 each, and we know how many of each he had. So this one, do we see 2 types of plans, or do we see 2 types of companies? No. We do see 2 types of flowers, but it's not like the flowers are competing, okay? Like with the cable companies or the phone plans, they're competing to see which one's going to be better, right? Okay, the flowers, we're not competing. We were given 2 total numbers. Whereas on 1 and 2, we were not given 2 total numbers. We were given 2 totals in general on this one. So our equations here ended up being R plus D equals 12. The number of roses plus the number of daisies is 12 flowers. The second equation was 2.5 or 2.50 R plus 1.75 D equals $24.75. Another thing I want to bring your attention to on why this one was different than the other ones, because we notice number 3 was set up a little bit differently than the first 2 were, right? Because we had plans and companies, and we said, oh, the first equation is the first company or the first plan, Olivia. Second equation was the second company or the second plan. But on this one, we had 3 of the same label. Okay, on example 3, we had 3 of the same label. We had a $, and a $. Can everyone look through on number 3 and see 3 of the same label? Mm-hmm. And exactly 3 of the same label. On examples 1 and 2, go ahead and look those over. Go ahead and look over examples 1 and 2 again. Go back to examples 1 and 2. Were there 3 of the same label anywhere and exactly 3 of the same label anywhere on numbers 1 and number 2? Look through them and tell me exactly 3, no more, no less, of the same label anywhere on the first 2. No. That is a good key, a good way to know how to set these up. So on 1 and 2, we had what we call the first plan, second plan option. First plan is one equation, second plan is another equation. Number 3, that was our curveball. We had 3 of the same label. Maybe even write yourself a note there on number 3, okay? Write yourself a note right above here on number 3 and say, we had 3 of the same label. And maybe even circle the dollar signs. You had 3 of the same label on example 3. And I would suggest you write that above number 3. I would suggest you write that above number 3. Aiden, you got that down, buddy? I would suggest that you write 3 of the same label, which I have written at the far right. I would suggest you write that above number 3. And maybe even circle the dollar signs, okay? Now let's move on to number 4. Brianna's family spent $134 on 2 adult tickets and 3 youth tickets at an amusement park. Max's family spent $146 on 3 adult tickets and 2 youth tickets. What is the price of a youth ticket? Okay. Well, raise your hand if you have a piece of important information we can pull from this. Okay, that's always a good first step. Important information. Okay. Tobin, lead me off.
The family spent $134 on 2 adult tickets.
Okay, so Bree's family spent $134 on 2 adult tickets. Is it just 2 adult tickets they bought with that?
And 3 youth tickets.
And 3 youth tickets, okay. Tucker, were you going to tell me another piece of information?
Max spent $146 on 3 adult tickets and 2 youth tickets.
Max's family had $146 on 3 adult tickets and 2 youth tickets. Okay? What else is important to know? Lainey.
What's the price?
Price of what, though?
Like you.
Youth ticket. Do we even care about the price of the adult ticket for our answer? No, we just need the price of the youth ticket, okay? So price of a youth ticket. That's the only thing we really need to know. Now, looking at this setup, don't blurt. I want you to think about this one and look back to examples 1, 2, and 3. Tell me whether you guys think we're going to set this one up more like examples 1 and 2 or more like example 3. Examples 1 and 2 were set up very similarly. Example 3 was different than the first 2. I want you guys to look this one over, example 4, and tell me whether you guys, and not blurt, but think about whether it's set up more like the first 2 or like the third. So go ahead and look those over now, please. Just think about it. Just think about it. Okay, raise your hand if you think you know whether it's set up more like the first or second or more like the third. Tucker, what are you thinking?
First and second.
Okay, why do you say that?
Because you have 4 of the same sign, 2, 3, and 2, 3.
Okay. Sorry, say 4 of the same label.
Yeah.
Okay, and what's the label you see 4 times?
It's just 2, 3, and 2, 2.
So those are just repeating numbers. So I wouldn't necessarily count that the same signs, but maybe repeating numbers. I do agree that it does look more like the first and second ones. Okay, because we don't see 3 of the same label here anywhere, do we? Do we see 4 of one label? Do we see any word in here 4 times? Or 4 times before we get to the question? What about tickets? Is that the word we see, Maddie? Okay, we see tickets in here 4 different times. Okay? That's not 3, is it? 4 is different than 3, right? Okay? So it's not like example 3, it's more like example 1 and 2, where there's like a first plan, second plan. But wait, here, are there phone plans and cable companies? No, what would be the first equation then? What would be the difference between them? They're not cable companies, they're not phone plans. What are they though?
Phone line?
Do we have 2 different families?
Yeah.
Yeah.
Bree's family, Max's family. So the first equation is going to be for the first family. Second equation is going to be for the second family. Does anyone have an idea on what the first equation might end up looking like? Well, what numbers go with Bree's family? Or Brianna's, Tobin?
134 and 3.
134, 3, and what else? 2. $134, 2 adult tickets, 3 youth tickets. That's what goes with it, right? Okay. Do we know how much an adult ticket is? No. But Bree's family spent whatever that is times 2, right? On the adult tickets? Because they got 2 adult tickets, right? So what could we call the price of an adult ticket if we don't know it?
A.
Okay, cool, A. So we could have 2 times A. Would that be how much they spent on adult tickets?
Yeah.
Okay. What about the youth tickets?
3Y.
Plus 3Y for youth. Now what would 2A plus 3Y equal?
134.
The $134 they spent in total.
What?
Huh?
I was confused.
Okay. So we have 2A plus 3Y equals 134 because 2A, A represents the adult tickets.
Oh.
Y represents the youth tickets. So because Bree's family bought 2 adult tickets, they paid 2 of the adult ticket price, which is A, and 3 of the adult ticket price, or the youth ticket price, so 3 times Y. And that's going to give them the total of $134 they spent. Does that make sense to you guys how we get this equation or no?
Yes.
So, can anyone tell me what my second equation might be? Lainey.
3A
Okay.
plus 2Y
Yep.
equals 146.
Equals 146, okay? I would agree with that. 3 times the price of the adult ticket, because for 3 tickets, plus 2 times the price of the youth tickets for 2 tickets equals 146. Now wait, quick question, guys. This is kind of random, okay? Not necessarily we need to know this, but let's just think about it for a second. If you guys go to an amusement park, who's more likely to cost more, an adult or a youth?
Adult.
Usually the adults cost more at places, okay? Like if you go to the movies or go to even to a sports game, okay? Usually the adults cost more to enter than kids, okay? So would it make sense that even though both families bought 5 tickets, why does Max's family spend more? Yeah, Lainey?
Because they bought 3 adult tickets.
They bought 3 adult tickets instead of 2. So even though they bought 1 less youth, they bought 1 more adult, and that's why their cost goes up. Okay? Now, do we have a system of 2 equations here? Okay? Now, we can solve this a few different ways. We talked about how we have graphing, elimination, and substitution. Is this one set up for graphing right now? Okay, probably not. Why not?
We don't have a graph.
There's no graph.
Yeah.
Okay? And are these in y equals mx plus b form like we like to graph in? No, so also like kind of doubly not set up for graphing. Okay? Well, are these set up for substitution?
Yeah.
What's it mean to be set up for substitution? What do they have to have?
Lined up.
You're thinking elimination.
Y
Be equal by something.
Y is by itself.
A variable is by itself. Some variables by itself. Is there a variable by itself here?
No.
No, I would argue it's not set up for substitution. Is it kind of set up for elimination?
Yes.
Yeah, it's lined up. Everything's in the same order, right? But if we add right away, are we going to eliminate anything?
No.
No, okay. But I would argue it's more set up for elimination than substitution because at least everything's lined up. So if you multiply one or both equations here, you're done. Whereas for substitution, we'd have to get a variable by itself, and that would create fractions. Do we want to deal with fractions?
No.
No? Okay. Elimination's our way then. So we're going to do elimination here. Now for elimination on this problem, we want to get one of the variables to have the same number for the coefficient, different signs. Well, can 2 turn into 3? Can we multiply 2 by anything to get it to 3?
Yeah.
Not a whole number.
Oh,
Okay, what about 3 to get to 2?
No.
No, okay. What about the other one? Oh, the same numbers, okay. Well, what could we multiply 2 and 3 both to? 6? We can multiply them both to 6. Okay. What would 2 have to multiply by? 3 or a negative 3, right? Because we want them to be different signs. And what would the 3 have to multiply by? 2. Now, could we also instead eliminate the y's maybe? We have to multiply the top by maybe a negative 2 and a positive 3.
Yeah.
Would you guys rather multiply the top by the 3 or the bottom by the 3? That's really your choice here. Okay, more people said top than bottom. So we're going to multiply the top one by negative 3. and the bottom one by 2. So if we multiply this top equation by negative 3, negative 3 times 2a is
6A.
negative 6a. Negative 3 times 3a,
Negative 9.
negative 9a. Equals negative 3 times 134. Okay, let's do this off to the side. 134 times 3. What's 3 times 4?
12.
12. What's 3 times 3?
9.
9 plus 1? 10.
Yeah.
3 times 1, excuse me? 3 plus 1?
4.
4. 402. And it's a negative 402. Yeah. You're right. Maddie had a good call here. It should be negative 9y instead of negative 9a. Thank you, Maddie. Let's do our second equation. 2 times 3a.
6.
6a. Very good. 2 times 2y.
4.
4y. Very good. Equals 2 times 146. Okay, well, let's do this off the side. Okay. Alrighty. Maddie's already got this one. 292. Nice work. Okay. Questions on how we got these equations or why we have these new equations in the purple? Okay, now what do we do with them?
Solve.
Add them together. What's negative 6a plus 6a?
0.
0. Did we eliminate a variable?
Yeah.
Good. That's a good sign. Elimination, you want to eliminate a variable. What is negative 9y plus 4y?
Negative 5.
Yeah, negative 5y. Different sign, subtract. 9 minus 4 is 5. Keep the sign of the bigger number. Negative 402 plus 292. Are those the same or different signs? Different, so we subtract. 402 minus 292.
110. Negative 110.
Okay. Well, let's go and do multiply. 2 minus 2 is 0. 0 minus 9, we've got to borrow. 3 and 10. 10 minus 9 is 1. 3 minus 2 is 1. It is 110, and it is negative 110, like Mason said, because the bigger number was negative, okay? Can you wait one moment until we're done with the problem? Okay, thank you. Now we have this equation. We're like, oh, bet, a one-stepper. Let's divide by negative 5. Y equals whatever negative 110 divided by negative 5 is. Well, negative divided by negative is a positive. Okay? So we need to do 110 divided by 5. Does 5 go into 1?
Yeah.
Goes into 11 how many times?
Twice.
Twice. Does it go into 10 again?
Yeah.
Twice. So it is 22. Now, we know 22 means what? 22 is the... What's 22 represent? The Y, what's the Y represent?
You.
The youth ticket, the price of a youth ticket. Now, what was our question that we were trying to answer?
The price of a youth ticket.
Price of a youth ticket. Do we even have to go back and find X here?
No.
No. So here's also another way we could have picked which variable to eliminate. We wanted to keep the Y because our answer was the Y. Let's get rid of the other variable, okay? Good luck, Lainey. Good luck. Okay. Any questions on this one? Now, if you had found A first, would you have to go back and plug it in for Y? Yeah, you totally could. Is that a little more work?
Yeah.
I thought we
Yeah,
did
it is.
A. Oh, no.
No, we eliminated the A's.
Oh, it's...
Yeah, we got the A's to the same number, and it's a different sign, so they would eliminate. Okay? Any question on that one?
No.
Okay. Now we're going to practice some of these in a moment here, okay?